was launched in 2022, last year, funded by the BMWK. And the goal is to build a quantum cloud for Germany. In the project was the University of Stuttgart, Fraunhofer Focus, Jonas, and QMware. And today, with me, are three representatives that I would like now to welcome on stage. George, the CTO and co-founder of QMware. Rainer Sträter, the Senior Vice President Cloud Services and Digital Ecosystems at Jonas. And also, Michael Falkenthal, CTO and co-founder of Anacor. Great to have you guys here.
Thank you.
Thank you very much.
I hope if the tone is not working.
Not yet.
It's okay.
It's okay, beautiful. Thank you. So thanks for coming, guys. Jonas is the consortium lead of the Sequence initiative. Maybe, Rainer, you want to give a brief overview what the vision is and where you are in the process, because it's been like almost a year now.
Yeah, right. No problem. I can still hear myself better than the audience. Okay, better now. So, I mean, if you look around, there is a lot of energy here. But it's still a bit sort of quantum nerdy. But what we see at the same time is that the industry demands quantum solutions. They do have the problems, the challenges already now, and they need solutions. So how do we get what we built here from the research area into the industry? And I would call it democratizing of quantum computing. Make sure that we build services, because not everybody will have at home a quantum computer. And it will take some time, but they need to have access to quantum computers now. So the solution is that we build a service ecosystem, allowing to access quantum technology at any level today, from simulation, traditional cloud infrastructure, but to the real quantum computers as well, as presented this morning.
So with Sequence, you're aiming for that. You provide the access. We talked about that before with the opening panel. It will take a little while. From industry partners, corporates that are sitting here listening, like, why should they care? Why should they get involved now? Heike said that before, get informed. But you're actually building up a blueprint for people to start working on it now. So why now?
So the point is, we don't know exactly when quantum computing applications will be commercially relevant. And since we don't know it, we have to make sure if they become commercially relevant, we have to be ready with an integrated solution where cloud computing is together with quantum computing at once, and you can use your existing applications in optimization, in machine learning, AI, and simulation with hybrid quantum computing clouds. And the good news is, also the bad news, there is no integrated structure yet for quantum computing, and quantum computing is always a combination of classical computing and the quantum processor itself. So the so-called full-stack quantum computer does consist of a classical HPC where quantum processing units are integrated seamlessly and utilized for the existing applications, not for artificial use cases. And this is why we are now integrating with Sequence the processing units and the classical computers and the intermediate software layer together with the applications, and there will be an announcement on the application side as well.
Yeah, now you already teasered it a little bit, because we have a new face on the stage. Michael is the first time in this round. And Michael, maybe from Anacor, do you want to quickly explain a little bit about the Planck platform? Because that is your proprietary project. So maybe just for your background to introduce yourself a bit.
Yeah, of course. Thank you a lot. So first of all, we had now heard about Sequence as a research project which aims for exactly this kind of an integrated software stack, integrated deeply with the hardware itself. A couple of years ago, exactly in 2018, we already started also from the perspective of, let's say, an application architecture. So we asked ourselves here, some kilometers from here in the University of Stuttgart, so if this new technology comes up, how can we actually leverage it for real use cases at hand? And in this course, we got a fund for the Planck project, which is a research project, started in 2019. And in Planck, as a research project, we elaborated the Planck platform itself. And the Planck platform can sit on top of this kind of software stack, closely coupled with the hardware, as mentioned by Georg and Rainer before. And we at Planck, we mainly aim for providing you as users a kind of a sandbox to play around with quantum, but also, let's say, to once you have developed a solution, a quantum solution, to raise the solution towards payable services, of course. Yeah, so we have already this monetization perspective in mind.
So with Planck also already has a community. Can you share how many users are on the platform?
Yeah. Of course, so Planck, of course, as a research project, already got interest from more than 100 organizations, mostly from Germany and Europe. Some also from the US already. And based on this open community, this is also important for Planck. It's not a closed system, it's an open community. So everybody can start getting into Planck and start collaborating with all the partners there. So this is really also a part of this kind of a sandbox, not just from the technical perspective, but also from a whole community perspective.
And then, now that we know what Planck is and what sequence is, I know that we have some news today to tell. And Rainer, do you wanna share the news?
Thank you, yes, I will. So, I mean, as you have heard, there is a piece of the puzzle that is perfectly built in Planck. And there's another piece of the puzzle that we built with Sequence. For democratizing quantum, make sure that people can access it as a service. However, if you kind of look, there's a natural fit between both of them, and they fit together, and there's a win-win in joining them. So what we decided is really a mutual decision, say, hey, let's align forces, let's make sure that we can integrate everything into one solution, in one ecosystem, and that's the reason why we now, with Anakura and Planck, have them integrate as partners into the Sequence project to have one solution for the end users, including all the Planck features, the Planck customers that we have into the Sequence world.
Beautiful, like congratulations. Congratulations, that announcement was sent out this morning, and I love that we can now like also announce it here on the stage of Quantum Effects. So, yeah, Rainer? What?
I mean, let me add one thing. The question is really, when should industry start working with quantum? And looking back, I mean, many of us have been surprised by the wave of AI that was generated in February or in November last year. And we frequently get the question, when should you start thinking about quantum? And the industry thinks already about quantum. It's not that they're not started the journey. They know there's something coming. They're waiting even with the particular solutions and particular questions and demand they have. So what we need to do now is, from our side here, from all the audience here, we need to make sure that we build the bridge between what we have here as quantum technology available now, add it into an ecosystem like Sequence, and make sure that the industry can start playing with it. It's an ecosystem. They have to learn to use the technology. They will not do it in a month. Now with AI, we saw an adoption rate which was tremendous. It was amazing to see how fast organizations can adopt new technology. Why? Because it was simple to use. We do the same now with quantum computing. Build a service layer on top which is easy to use, that the industry, the German SMBs in particular, can absorb this new technology in their way of absorbing things, as a service, in an easy way to benefit from this, and start now learning about quantum computing by really experimenting with it, having an entire ecosystem which is fun to use, and then step by step be ready, when we are ready, to deliver the solutions in whatever time frame, next year, year after next.
So with Janos, you were saying, yeah, you have to get interested now. When did Janos start putting quantum technology on their strategic roadmap?
I was actually 2019,
okay.
Because Sequence, we had multiple phases where we started thinking about what the best Sequence would look like and how can we build services. And then we looked at Planck and see, well, there's something growing there which is really of cool interest. And then we take a while to find the right partners and find the people here that have the same mission to get quantum computing into the market. Mm-hmm. So with this kind of setup we have now with University of Stuttgart, Fraunhofer, QMware, now Anakura, you mentioned them, we do have the right setup to get the next level in building this quantum ecosystem for the industry and not just for the researchers.
So let's talk about industry, let's talk about use cases, especially in that setup with Planck. what kind of applications, use cases are interesting, and what industries are you already working with?
Okay, so the use cases actually are very, very broad. Interestingly, that means any HPC application we imagine today, which counts on parallelization and on GPUs together with CPUs, can be amended in a very fruitful way with quantum computing, in the sense that the GPUs accelerate the CPUs and the QPUs, the quantum processing units, will accelerate the GPUs. We let it open to the users in the space of AI or quantum machine learning, a better term, and in the space of optimization. We have a huge use case there, for example, with satellite mission planning with Thales, where we showed that in a space of 10 to the, in a problem space of 10 to the 1700, which is interactable for classical computing, even quantum algorithms on simulator backend gives an advantage on those problem spaces. And we see that there is Qiskit has more than 500,000 users right now, and there are many, many users trying to find out which quantum algorithms fit best to the hardware and could make a commercial quantum advantage as soon as in 2 or 3 years. And we are providing this platform to find this commercial quantum advantage by any one of you or the community worldwide, and to use that immediately in the industry due to the connection to the cloud and the UNOS cloud, of course.
Maybe you guys can talk a little bit more about concrete examples. So you mentioned Thales and the satellite mission planning. Is there something more that you could share? Concrete use cases.
Of course. So everything you can imagine where you have a big problem space, or you do not fear the uncertainty of quantum for exactly, so you don't need an exact answer. So like quantum AI, quantum neural networks is a very good use case where we are seeing, we have made such a use case with Evonik, for example, where we are optimizing those computational fluid dynamics problems for building vessels and mixing fluids. And we have seen that we could cut the cost of learning for the machine by 35% and together with an improved accuracy. So there is real concrete use cases. We have more than 100 use cases in the industry already done together with Terra Quantum, and they are all public, they are all open to evaluate and to re-benchmark on the newest machines.
So there was a recent study by McKinsey that said until 2030, 2035, there will be a potential in value by 1.3 trillion US dollars. So in which industries, they mention automotive, but when we say like in Europe, where do you see the players getting started? Where do you see the low-hanging fruits?
So maybe I can add on it, because low-hanging fruits is maybe a bit overestimated, but it's still leading-edge technology, right? So, but of course, maybe we can remember on the quote by Richard Feynman 40 years ago, and he stated, the father of thinking about a quantum computer, and he stated, well, if you want to simulate quantum systems, then why don't we do it with quantum systems? So this is the original idea of a quantum computer, and this is also what we see at the moment, that especially in this very simulation, close to quantum simulation topics, there are really huge potentials already. And of course, as George also mentioned, especially when it comes to optimizing things, or also problems like classification. So we have examples like improving fraud detection for credit cards or so. Special problems where you typically don't have so many data to learn using machine learning. Of course, there you can also improve your learning steps via quantum computer to boost those things. And I can just invite you to also visit the Blank platform at the use cases there, because Georg also already mentioned, lots of work has already been done in elaborating potentials in use cases. So we're not already there to really have this quantum advantage. So we have good evidence in different fields, but as a starting point, I can encourage you to figure it out. And there is no boundary between different domains, so quantum is omnipresent.
Okay.
And to be honest with you, I don't think there will be this one single application use case where everything starts making sense now. And we've seen it in many technologies. We've seen this 5G, we see it with AI. There are tons of use cases, and we don't know them already now. That's the reason why we try to push forward this ecosystem, allowing people, startup companies, even the industry in the different flavors and different sizes to really play around with the technology. And at the end of the day, it will be continuum. It will be standard CPUs we have, then we GPUs, and the GPUs kind of take over more efficient tasks of the CPUs, and as George said, then the quantum will take over tasks from the GPUs because they can do it more efficient. And efficiency is something which is key for us. And over time, it might be even that the service providers decide which of the platforms is the best one to use, but the users comes with a problem and say, hey, this is what I want to solve. Give me the right platform to do it. And maybe it's even a hybrid system, a mixture of platforms that we see. So looking ahead now, we will see a lot of technology coming into our data centers, but for time being, we build the ecosystem that allows people now get engaged and solve the problem that they do have already with the technology that we have available now. With all the computers, like IBM said, we had DLR, we had Bosch. So we have a lot of companies that provide technology and even quantum computers today. And what we integrate in Sequence as well is that we don't wait for another quantum computer that can be integrated in our data centers. No, we take the existing quantum computers and link them into the platform so we can use them now in a very easy way as a service, and don't need to wait until somebody builds the next quantum generation that will end up as a cloud native quantum chip.
So when we now come into how to get started, we heard there is the platform now, Planck. When there is a corporate so says, like someone in the audience, I want to start now. Like how does it work?
I can start again. So first of all, I think it's really crucial to understand a little bit what Planck has done already. There is a lot of knowledge, a lot of research that exists already. Make yourself familiar. It's very easy to access. So understand the problem domain, the solution domain that is provided by the really good examples, and not just Planck as an example, but Planck as a platform for many solutions and examples. Secondly, please keep in touch with Sequence, because we step by step now commoditize, democratize the service that you have available in Planck already, but now make it easy accessible. Take your credit card, just buy a service, and then leverage the entire ecosystem. You don't need to send a fax or something like even weird messages, contract paperwork. No, it's like using cloud. Quantum, getting access to quantum will be like using a cloud. And that's what we need to do to scale it out. And there, my recommendation is, if you don't have a strategy about quantum computing, you should definitely go for it and build a strategy. If you want to understand what quantum computing can do, there are good use cases on the Planck platform, and reach out to Sequence and make sure that you're in line with the platform and can use it when it's ready.
And I know some of you are building quantum technologies, and if you want to integrate those quantum technologies into high-performance computers and classical data centers, then come to QMware. We are doing that together with you, and we are integrated in Sequence. So as soon as your technology is integrated in QMware systems, they will be also available in the German Quantum Cloud.
Yeah.
Maybe something to focus on, because you said we're not talking about big enterprises. We were talking about Bosch before, but you specifically mentioned small, medium enterprises. So maybe you want to say something about that, how they can start working with quantum.
Well, I mean, first of all, don't wait. And that's true for many things, but for quantum as well. Get engaged first, but secondly, we can already simulate quantum problems on a standard traditional cloud infrastructure together with QMware on special hardware, so we can simulate now. So my recommendation is get engaged now, identify your problem and solution domains, and especially for the startup companies or the people that build new innovations in that sector, just come to us and we help together making it scaling out into the cloud infrastructure, into the quantum computing infrastructure that is able to consume by the SMBs in the future. We have plenty SMBs that either have very specific use cases, like you said, the fluid simulation. We have it not only in the car industry, we have it in the oceans. So the maritime sector has a lot of simulations at the moment, trying to find best places for seagrass, offshore wind parks. So there's a lot of tons of data where quantum already helps now. Now, it's too difficult to name all the different particular use cases, but try to really find out what Planck is doing now and then adapt it to your problem domain and figure out if quantum is already a solution now, and then get into the quantum space by starting with simulation, starting by technologies available now, and then be ready when the large-scale infrastructure is ready to use in an easy way.
And maybe just to focus on that one more time, because George, you already mentioned it. So with Sequence, corporates get access to a quantum simulator, but then also to native quantum hardware. George, maybe you want to elaborate on that a bit.
Yeah, exactly. So what we have managed to build is, that's the reason why the name is QMware, it's a virtualization layer on quantum hardware for the computational tasks. And quantum hardware can mean a gate-based machine, can also mean an analog machine, and all together comes it to an operating system where we can use microservices and APIs in order to connect to commercial cloud systems. And the Sequence project is exactly building such an abstraction layer for a platform where we on top can host any quantum engineering environment and application environment for the industry. So as we do with Planck. So it's really an end-to-end solution in the commercial sense. I always compare that. I say, okay, what is quantum advantage? We know since the algorithm of Peter Shor that in the early 90s that there is a theoretical quantum advantage. Then in 2019, Google showed there is also a technological quantum advantage. If you want to calculate a distribution of probabilities, there is no commercial quantum advantage yet because we don't have a use case for those applications. But from the technological to the commercial quantum advantage, there is a simple step which we provide with an ubiquitous open platform for hybrid quantum computing, including all the backends to one front end for your application.
Of course, I'm a little bit curious. I don't know if you can talk about it. With Sequence, can you talk about which kind of quantum chips you're going to integrate?
Oh yeah, sure.
Yeah.
So we started up front with IBM in Einingen, of course, not far from here. So you can use those platforms by our consortium partner Fraunhofer. Then we have already announced a photonics processor together with Quix. They are just right over here. And this will be available in about 6 months. And then we are also integrating other superconducting platforms. We are also in close discussions about that with IQM, for example, as you can imagine. All the players in the German quantum space, actually. And there will be another announcement also for an not European quantum processing unit manufacturer, which will be announced soon, I guess, this month later.
Coming up.
For another technology, another platform with cold atoms.
Beautiful. I will give up for the questions from the audience. We have our assistant over there. So if somebody has a question, then please just raise your hands and she'll come to you. Maybe to have like a closing question on the panel, if you want to look into the future. So Sequence is now for 1 year, you're integrating Plunk. What are the next milestones and like KPIs for success?
So, I mean, the first KPI is that you can use quantum computer like you use cloud today. So that would be my kind of first milestone. And then secondly, we know that quantum computing is not just one single service, it's an ecosystem. And what we need to build now is all the things we need to build ecosystems here, which is a bit more than just a service access to a quantum computer. So all the development environments to develop kind of new things, to take existing components, enhance them. And we see actually the same in AI now. With large language models, we have foundation models. Now they take contexting and the fine-tuning. So they take existing models and make it better. And this is an ecosystem that just builds, started late last year. Now we will see now this year the same and next year the same in quantum computing. We will have a service available and we build the ecosystem surrounding it to make sure that everybody can use quantum computing not just as a service, but for developing and enhancing their own technology, their own applications that they want to put into the cloud, in the quantum world.
Mm-hmm.
And maybe I can add on it because this is exactly also what we strive for at Plunk with, let's say, the whole community-based approach we have at Plunk. And so you can also imagine it like a, let's call it the app store kind of thing for quantum solutions. And this, the neat thing about it is that especially as a SME, you don't have to develop the whole stack on your own, but you can also rely on others. Maybe there are already some nice solvers for specific quantum problems out in the wild. So then you can build really on them to add then the value your profession comes through, right?
Beautiful. Then I hope that we'll meet each other next year on stage again, and then you'll tell me about the next QPU, and hopefully also then with some people with new great use cases. I'm looking into the audience. If there is somebody who wants to raise a hand for a question. I think there was a lot of information. So thank you so much. Let's give them an applause. Thank you very much.
Thank you.
Please.